Hey everybody, my name is Calvin, and I'd like to share with you an interest of mine and something that has often made me stop and think. How does that thing float? Have you ever wondered how those unthinkably massive ships in Darling Harbour float? When I'm crossing the harbour bridge, looking out the window of the bus, admiring the beautiful city I live in, I often notice that I'm eye level with the top floor of a cruise ship, and I rack my brain as to how something so huge and heavy can float. To understand this question, we need to think about density and Archimedes' principle. Most of us are able to look at objects and have a good understanding as to what things will float and what things will sink. We generally think that light objects float and heavy objects sink. But the weight of an object can't determine if it will float, because a tiny pebble will sink and a huge cruise ship floats. So if the weight of an object doesn't matter, what does? There are two fundamental concepts we need to talk about on our quest to understand how boats float: density and Archimedes' principle. Firstly, density. It can be described as how much mass per unit of volume an object has. So think of these two identical cylinders. One is filled with nothing but the air inside, while the other is full of concrete. These cylinders have the same volume but a much different mass. Only one of these two cylinders will float, and I'm sure we could all guess. That's right, the container filled with air would float, as it's less dense than water. This is crucial to understanding how such heavy things like cruise ships float. The materials that cruise ships are made of are generally more dense than water, but thanks to the ingenious way ships are constructed, they contain huge amounts of air inside, which causes the overall density of the ship to be less than the water. Density isn't the only reason for why things float. We need to talk about Archimedes, and more specifically, the Archimedes principle. He was, simply put, a genius. He lived in Greece over 2,000 years ago, and as the name suggests, created the famous Archimedes principle, which states that an object in fluid will experience an upward force which is equal to the mass of water being displaced. This upward force is known as the buoyant force. Anyone who has gone swimming has experienced this force firsthand. Displacement is what happens when objects are put in fluid. Just like when you get in the bath or put ice cubes in your drink, the water level rises. The volume of water changes exactly equal to the volume of the object which is introduced, either your volume in a bath or the volume of ice you put in your drink. To help understand the buoyant force, think of trying to push a beach ball underwater. You can noticeably feel something pushing back on the ball as it goes underwater. That is the buoyant force. When you push the ball underwater, you are experiencing the buoyant force equal to the total mass of water being displaced. Boats are designed so they displace a much greater mass of water than the mass of the actual boat, which means the buoyant force is stronger than the downward force. The magnitude of gravitational force depends upon the mass of the object. When the buoyant force overcomes the force of gravity, this allows the boat to float with ease and also means you can bring all of your friends and luggage on board. So to summarize, boats float for a few reasons. The boat will overall be less dense than the water because of all the air inside. They are designed so that they displace a larger mass of water than the actual mass of the boat. So the buoyant force is strong enough to overcome the force of gravity, which keeps the boat on the surface for the lucky people to enjoy. Thank you for listening.